So today we're going to move into the natural logarithm. First thing I want to review quickly, common log. Common log, do you remember what base always goes with the common log? 10. So common log is base 10. So remember that means if you just have, for example, the word log, no base number written, it's always going to be a 10. That is our common log. So our natural logarithm comes into play when we have a base of e. So if I start with f of x equals e to the x, I want to find the inverse of it. What's our first step? Yep, f of x gets changed to y. And then what do we do? X is the y is the x. And then we have to solve for y. So how could we rewrite this solving for y? Close. Log base e of x. But that's not actually how we write it. E, because it's that natural phenomenon that exists, E got its own special little symbol because it's so important. So E is important, so it gets its own symbol. So when you have a base of e, instead of the log, even though it is still a log, we use what we call the natural log. So we use those two letters ln. And whenever you see those two letters ln, you got to know in your head that means we have a base of e. Just kind of like when you see a log with no number, you know we have a base of 10. So ln, comes from that natural log, and I know it's backwards because those French people like to say things backwards. So it's le naturel, ln. Also the log of Napier, so ln. That's why we use those two letters. So if we have an exponential equation that we're used to using, for example, y equals 2 to the x, our base here is the number 2. So for this one, when we write the inverse of it, we're going to use a log. So our inverse for that would be y equals log base 2 of x. But whenever we have an exponential equation that uses a base of e, our inverse is going to involve the natural log of ln. So that would become y equals ln of x for its inverse. So again, ln, this tells you base is an e. So evaluating, it's very similar to evaluating logs. Logs means you're finding the exponent. ln means the same thing. You are finding your exponent. ln of e, this is kind of like what we were just doing on our warm-up. Whenever your base and this number are the same, it always simplifies to a 1. Same thing happens with ln of e. So remember, ln means you have a base of e. You're trying to take it of e. So that always simplifies to a 1. ln of 1 simplifies to a 0 because it's asking you what's the exponent on e that gives you a 1. Anything to the 0 power is 1. ln of e to the 5th, remember those exponents come down in front, just like it did with your logs, because again, still a log, same rules all apply. But again, what does the ln of e reduce down to? 1. So that would just be a 5. It just ends up being whatever that exponent is. So for our last one there, d, instead of the square root of e, how could we rewrite that? e to the 1/2. So then again, this 1/2 would come down in front, but the ln of e reduces to a 1. That would just be 1/2. It's whatever that exponent is on the e. That's what that reduces down to. Type under your y equals the ln of x. Get yourself the graph. Let's see what it looks like. Start looking at it. So you should have a graph that looks very similar to mine. Definitely need to be drawing in those vertical asymptotes. Also, just like we would for our log graphs. It looks like a log graph because it is still a log, even though it's using ln instead of that word log there. So what is our domain of our graph over there? X is greater than 0, just like with our log ones. Our range, element of the reals, or some people prefer the interval notation, still negative infinity to positive infinity. Our x-intercept is at 1, 0. And our vertical asymptote is at x equals 0. So just like our log graphs, we can still transform these ones around. It's going to change some of our key features there. So if we look at this first one here, letter A, y equals the ln of negative x. What is our transformation? If I put that negative in front of x, reflect over the y. So go ahead, type that into your calculator. Let's look at the graph quickly. Figure out the domain, range, x-intercept, and the vertical asymptote for ln of negative x. Your graph should come up looking like that one up on the board. So what would be our domain this time? Less than 0. Because that one's going to the left instead of the right like all the other ones do. Does our range change though? No. Our x-intercept does change. This time where's our x-intercept? -1, 0. Vertical asymptote doesn't change. That's still going to be at x equals 0. All right, letter B. What's going to happen with that one with that -5 at the end? That's just going to make it move down 5. It would make it move to the right if it had parentheses around the x minus 5, but it doesn't have those parentheses. So that just means it's going to shift it down 5. So what would be our domain? It would be x is greater than 0. It's still going to all be to the right of that y-axis. Our range is the same. X-intercept, that's not showing up on your graph, is it? No, so we'll go over that one in a second. Vertical asymptote would still be at x equals 0. So if we go back to our x-intercept for a second there, you have a couple options. You could change the window on your graph until you find it. It'll take a little while, but that's very possible. Algebraically though, your x-intercept is when your y is a what value? 0. So if I put a 0 in for the y of my equation, I'm going to try to solve for x. So I would add my 5 over first. And that would give me 5 equals the ln of x. And then let's rewrite this in exponential form. Again, what's our base for ln? E. The exponent is the 5. And then that equals your x. So our x-intercept is going to be at e to the 5th. So if we leave it as e to the 5th, which is perfectly fine, we refer to that as exact value because we haven't rounded a decimal or anything. Or if you did type it in, it's like 148 point something is where it would end up being. So sometimes finding it algebraically is going to be the way you want to go about it. Then looking at our last one there, letter C, we have 2 transformations that are happening. The negative out front means it's doing what? Yeah, reflect over x. And then the +2 means it's going up 2. So we had that 2 things, reflecting over the x, and then it's moving up 2. I'll give you a second. Go ahead, type that in. You can look at the graph if you don't already have it there. So our domain is what? 0. Our range, YER, or negative infinity to positive infinity. Vertical asymptote is still going to be at x equals 0. Your x-intercept, that may show up there, but it's not at a nice number. So let's go ahead and do that algebraically again. So if we put a 0 in for our y, we would want to subtract the 2 over first. So I get negative 2 equals negative ln of x. I'm going to divide by that negative 1 to make everything positive. So then rewriting it in the other form, exponential form, we would get e to the second equals x. So that's where our x-intercept will be this time, is at e to the second. Last class we went over 3 log properties, or rules if you will. ln has the same exact rules. So if you are multiplying 2 things together, that means you have to add their ln's. So ln of a times b would be ln of a plus ln of b. If you are dividing them, that means you subtract their ln. And then where do our exponents go? Down in front. That would be b times the ln of a. So all the same rules, just we're writing ln instead of log. So expanding, again, it goes quotients, products, exponents. That is our order we want to deal with them in. So we would have the ln of x cubed y minus the ln of e squared. It's always numerator minus the denominator. So how would we further break down this one, the x cubed y? How would we rewrite that one? Perfect. Minus 2 ln e. So then what do we say the ln of e reduces to? 1. So our final answer would actually be 3 ln of x plus the ln of y minus 2. That ln of e is going to show up a lot, so you got to remember to always reduce that down to the 1 if it's there. So b, again, I'm going to rewrite that to get rid of my square root sign. I mean, not really getting rid of it, just rewriting it as e to the 1/2 instead. So numerator minus the ln of the denominator. So e to the 1/2 minus the ln of a cubed b. So our 1/2 comes in front. We have 1/2 ln of e. Remember, this denominator, we need to put it in parentheses. So it'd be minus parentheses 3 ln of a plus ln of b. So we got to clean a couple things up. Again, ln of e reduces to 1, so this would be 1/2. The other way we could take care of the denominator is to distribute that subtraction sign through, so you could make it minus 3 ln of a minus b. Or you could leave it like this in the parentheses with the subtraction out in front. Either one of those are fine. So condensing, we got to go back the other way. So any numbers in front of ln's are exponents. So within that first set of parentheses, that would condense down to be the ln of a squared over b. And then we got plus. So again, that 1/2 is going to be an exponent on our c. So this is going to be times c to the 1/2. A lot of times you'll see them actually change it from c to the 1/2 back into the square root of c. Sometimes you'll see them actually put the square root of c in the numerator with the a squared. It's all the same thing. So the other thing we're going to do today is we're going to start solving some ln equations. So when we are solving ln equations, you want to first isolate the ln of whatever. So get the ln just by itself. Then you put it in exponential form. And your last step is you would actually finish solving for x. Sometimes once you get in exponential form, you just have to add or subtract or multiply or divide to get your final answer there. Now, if you notice, it did say express our answers in two forms, exact value form and to the nearest thousandth. So we're going to have two answers for each of these questions here. So for letter A, first thing we would do, add our 5 over. Because again, we're trying to get that ln by itself. So adding the 5. And then we would want to divide by the 2. So doing that, now our ln is isolated. We got the ln and then the parentheses, the x plus 3, that's all by itself. So now we can move on to step 2, where we're going to put it into exponential form. So again, with ln, what's our base? E. What is our exponent? 4. And it's going to equal x plus 3. E to the 4th equals x plus 3. So for this one, because we have x plus 3, I need to subtract this 3 over. And leaving it as e to the 4th minus 3, that is our exact value. So that is the first way they wanted us to leave the answer. So remember, e is an irrational number, keeps going on forever. So we didn't want to round it yet. Our exact value means we haven't rounded anything. So go ahead, type that into your calculator, e to the 4th, and then minus 3. We'll get our decimal answer that they also wanted. Which we should get 51.598. Nearest thousandth is 3 numbers after. All right, let's try this again. The letter B, again, we want to isolate the ln. So what do we want to move first? The 3. So I subtract my 3 over. That gives me an 8 over there on the right side. So now how do we get rid of that 2/3? Let's multiply. So 8 times 3/2 would give us a 12. So now our ln by itself, we got ln in the parentheses. So that's as isolated as it's going to get. So this becomes e to the 12th equals 0.5x. So now for our exact value, you can't sit here and tell me divide by 0.5. You can't have a decimal in your fraction. So how do we clean up the 0.5? What's our other way of doing it? 0.5 is 1/2, yep. So what is, multiply by 2, flip and multiply. Multiply by 2. So there's our exact value, 2 times e to the 12th. So go ahead, type in 2e to the 12th. We'll figure out what our value is to the nearest thousandth. It's going to be a really large number. $325,509.583. There was a 2, but the 8 after it makes it round up to a 3. So our last thing in our notes for today, finding the inverse. Already has a y in there, so step 1 of finding our inverse. Switch our x and our y. So then finding inverse is similar. You got to get the ln completely by itself when you're trying to solve for your y. So I'm going to subtract that 2 over. So x minus 2 equals ln of y minus 8. Now the ln is isolated. I'm going to put it into exponential form. Base is an e. My exponent is that x minus 2. And it's going to equal our y minus 8. So then our last step would just be to add that 8 over. So e to the x minus 2 plus 8 equals y is our inverse.